Hello everyone, welcome to Unit 5. Today we're going to be talking about the substitution method for solving linear systems. Up to this point we've learned what a linear system is, and we've also talked about one method to solve it where we can take two things that are equal to each other and set them equal to themselves, right? So that's called the equal values method, which was covered in the last lesson. We're going to talk about this method called substitution method and learn what that is, and then learn to apply it to a linear system so that we can find the solution to that system. All right, so let's talk a little bit about substitution. And the idea of substitution in math is that you can replace any part of any equation with something else that is equal. All right, so if we have a piece of information that tells us like x is equal to something else, we can take that x out and replace it with the something else. All right, so the method of solving by substitution works by solving one of the equations for one of the variables, and you get to choose, which equation you do this with and which variable you solve for, and then plugging that back into the other equation, right? That's where the substitution happens for the chosen variable, and then solving for the other. Now, it's a mouthful, and trust me, it's better seen than heard. So let's take a look at an example and see what that looks like. Okay, so I have a system of equations, right? So I have two equations here, y equals 3x and 2x plus y equals negative 10. Just a bit of advice, and it's a personal preference, but I like when I get these systems like this, I like to write them side by side like this rather than stacked on top of each other like this, especially for substitution, and you'll see why in just a minute. Okay, so here, this would be a little bit difficult to do the equal values method because both of these equations are not set equal to y. Okay, so like this one has something on the side of the equation with the y, so we don't have y by itself. But we can use a substitution here to replace y. Right? So I can take this variable y and I can actually substitute it for something else, because over here in this equation, they tell me that y equals 3x. Right? So 3x is the same thing as y. So I can take this 3x and I can come over here to this equation and substitute it for the y. So let me rewrite it with that substitution made. Right? So I can say 2x plus, now instead of the y, I'm replacing that with the 3x. I'm going to say 2x plus 3x equals negative 10. Right, so that y turned into a 3x using substitution. Now what I have here is an equation, and there's only one variable. You'll notice now there's only x's and instead of x's and y's. Okay, so this becomes something that we can just straight up solve, right, by getting x by itself. So I can do a little bit of combining like terms, right? So I got a 2x and a 3x, which combines to give me 5x's. And then I can get x by itself by moving the 5 to the other side. Since this is multiplication right here, I would have to divide by 5 on both sides. Right? Whatever I do on one side, I have to do on the other side. So the 5's cancel out, leaving me with just x. And over here, negative 10 divided by 5 is negative 2. Right? So I just solved for x, but remember, for a system, we need to solve for both x and y. So I know what x is, but I'm going to have to use this negative 2 to help me figure out what y is going to be. So again, I'm going to go back to one of my original equations here. I'm going to use this one because it's a little bit easier than trying to use this one. So I'm going to use this first one, and I'm going to say, well, if y equals 3 times x, and now I know x is negative 2, then I can say y equals 3 times negative 2. Right, so it's like I made a substitution again, right? I know x is equal to negative 2, so I'm taking this negative 2. Let me get a different color here to demonstrate that. Right, I can take this negative 2 and substitute it for the x. Right, so it's like doing an input, okay? So now I can say y equals negative 6, right? Because 3 times negative 2 is negative 6. So when I write my solution for a system, we would say x equals negative 2, y equals negative 6, and sometimes we write that as an ordered pair. Right? So I would say negative 2, comma, negative 6. And your practice problems are going to ask you to write your solutions like this as an ordered pair on MyOpenMath. So once you find out what x and y is, write it as an x comma y ordered pair with your parentheses and everything. Okay. All right, so that's an example of the substitution method. Let's do one more just to make sure we got it nailed down. And so again, here we are given two equations, and I like to write them side by side, so I'm going to do that. So I'm going to say y equals 3x plus 10, and then I'm going to say negative x minus 3y equals negative 10. Okay, so there's my two equations. Now this one is solved for y, right? So I know that y is the same thing as 3x plus 10. Let me grab a different color here. I'm going to take this 3x plus 10 and say that's the same thing as y. Okay, so if I look over here in this equation, here's my y. So this is what I'm going to substitute. I'm going to take this y out, and I'm going to substitute in this 3x plus 10. Okay, so let me go back to my pen. So this 3x plus 10 is coming over here and replacing this y. So we're going to get negative x minus 3, and then I'm going to use a parentheses to help me with the substitution here. I'm going to put in 3x plus 10 and close off the parentheses equals negative 10. So you'll notice every part of this equation stayed the same, including the 3 here. The only thing that changed was the y, right? The y became this 3x plus 10. And now I have an equation that I can solve. All right. So to solve this, I'm going to have to get rid of these parentheses here. So I'm going to have to distribute the negative 3 into this parentheses, right? So I have to distribute it to both things, the 3x and the 10. The negative x is not being distributed, so I'm going to leave that alone for right now. And then I'm going to multiply, right? Negative 3 times 3x is negative 9x. And negative 3 times 10 is negative 30. And then I haven't done anything on the right-hand side of the equation yet, so I'm going to leave that alone. All right, so now I'm looking over here. I notice that I have two terms with an x in it, right? So I have a negative x and a negative 9x. I can combine those together, right? I can actually subtract those two things. So I can say negative x minus 9x is negative 10x. All right, and then our goal here is to get x by itself, so we know what x is. So I'm going to move the negative 30 over here with the negative 10. Since it's a minus 30, I'm going to do the opposite and add 30. And whatever I do on one side of the equation, I have to do on the other side. So I'm going to go ahead and add 30 here, which means these would cancel out. All that's left is the negative 10x. And over here, negative 10 plus 30 is a positive 20. All right, and then last step here, this is multiplication, so I'm going to have to divide. So I'm going to divide by negative 10 on both sides. So the negative 10s cancel, and we get x by itself. 20 divided by negative 10 is negative 2. All right, so now we know what x is. But remember, this is a system, right? So not only do we need to know what x is, we need to know what y is. Right, we have to find out what y is going to be. So again, I'm going to use that first equation. I'm going to use this right here. I'm going to say y equals 3 times x. But remember, now we know x is negative 2. So I'm going to say 3 times negative 2 plus 10. Right, and then use my order of operations here. 3 times negative 2 is negative 6 plus 10. And negative 6 plus 10 is 4. Right, so now we know that y is 4. And then remember, my open math is probably going to want you to write this as an ordered pair, so we're going to write it as negative 2, comma 4, right? X, comma y. All right, guys, hopefully you found that helpful. I want you to give the practice problems that come after this a try. All right, let me know if you have questions in the Zoom chat.